Microsoft just built its own AI chip to break Nvidia's grip. A startup making a single chip the size of a dinner plate is now worth $23 billion. And in China, a humanoid robot just moved in a way that doesn't look programmed at all. These three stories aren't separate. They're part of the same AI shift. And what's happening right now is going to reshape who owns AI compute, how models actually get trained, and where AI stops being software and starts being something physical that changes how the world works. So let's talk about it. AI just hit three bottlenecks at the exact same time. First, compute cost is exploding. Running cutting-edge AI models costs hundreds of thousands of dollars per day. Cloud margins are getting crushed because inference is expensive and nobody figured out how to fix it yet. Second, model scale is hitting walls. You can't train bigger models with the same hardware you trained the last generation with. You need something fundamentally different. And third, robots. AI has been locked inside data centers for years. Now it's trying to move, balance, and interact with the physical world in real time. That's a completely different problem. What we're watching isn't just better AI, it's AI breaking out of the data center and into the real world. And the companies that control how that happens are about to become very, very powerful. For the past 5 years, every cloud company on Earth has had the same dependency. Nvidia. Nvidia makes GPUs. Microsoft, Google, Amazon, everyone needs them. And Nvidia knows it. They've locked in their market position so completely that cloud companies are basically paying whatever Nvidia charges. The margins are insane. But here's the real problem underneath that. Nvidia's chips were designed as general-purpose graphics processors. They're flexible, they're powerful, but they're not purpose-built for what hyperscalers actually do. They're built for everything, which means they're optimized for nothing. And when you're running millions of inference requests per day when cost per token is the difference between profit and loss, general purpose stops being good enough. You need something built specifically for your workload, something you control. Enter Maia 200. Microsoft didn't announce Maia 200 at some big event, it leaked. Researchers found references to it in benchmarks and documentation, and that's intentional. Microsoft is building this quietly because they don't want Nvidia to respond before it ships at scale. Maia 200 is a custom AI accelerator, not a GPU, not a TPU knockoff. A completely custom chip designed from the ground up for one thing, running inference on Microsoft's own models on Azure at massive scale. The chip is built around Microsoft's own tensor architecture. It handles the exact operations that Copilot, Grok, and other enterprise models need. Matrix multiplication, attention mechanisms, activation functions, all optimized at the hardware level for what Microsoft actually runs. And here's what makes it different from what Nvidia does. Maia 200 isn't trying to be fast at everything. It's trying to be cheap and efficient at the specific thing Microsoft does all day long: inference. Running models that are already trained, just answering questions and generating responses billions of times. Inference is where the real cost is. Training is expensive once. Inference is expensive forever. If you can cut inference costs by 30%, 40%, 50%, that changes the entire economics of the business. This is the same playbook Apple ran with Apple Silicon. Same playbook Google ran with TPUs. Build your own chip. Control your own stack. Stop paying tribute to a chip maker who doesn't care about your specific problem. But here's what makes Microsoft's move different. Apple Silicon, that was about efficiency and battery life and controlling the user experience. Google TPUs, that was about training big models cheaper than anyone else. Microsoft Maia 200 is about something else. It's about breaking free from the only company that has real leverage over cloud AI right now. The key insight here is this: Maia 200 isn't about beating Nvidia on raw power. It's about Microsoft never being held hostage by Nvidia again. It's about telling your investors and your customers that you control your own destiny in AI. You don't wait for Nvidia to ship a new GPU. You ship what you need when you need it. And once you do that once, you do it again and again. Hyperscales will follow. Amazon will build something. Google will push TPU harder. The golden age of Nvidia's monopoly isn't over, but the end of it is visible now. While Microsoft is building something in secret, Cerebras is doing the exact opposite. They're building something so radical that people didn't believe it would actually work until they saw the data. Cerebras makes a chip called the Wafer-scale engine, and the name is literal. It's not thousands of GPUs connected together. It's not a massive multi-chip setup. It's one single chip, the size of a dinner plate. A standard GPU has maybe 10,000 to 20,000 cores. The Wafer-scale engine has over 900,000 cores all on one piece of silicon. Now, why does that matter? Because every time you connect two chips together, you lose time and energy moving data between them. It's called the bandwidth bottleneck. You can have the fastest chips in the world, but if you spend half your compute time waiting for data to move from one GPU to another, you're wasting everything. Cerebras says fine, we're not connecting chips, we're putting it all on one wafer, so all 900,000 cores can talk to each other without leaving the chip. No interchip communication overhead. No waiting, just compute. Is it radical? Yes. Is it experimental? Yes. Does it actually work? That's what investors are betting $1 billion on. Cerebras raised a Series C at a $23 billion valuation, $1 billion in a single round, for a company that, 3 years ago, nobody thought would survive. That's not normal. That's not a tech startup getting a big funding round. That's institutions betting that the entire paradigm of AI training is about to shift. Here's what changed. Frontier model training is getting absurdly expensive. OpenAI, Anthropic, DeepSeek, everyone is spending billions on compute to train the next generation of models, and they're all dealing with the same problem. Interconnect overhead. Moving data between thousands of GPUs is slow. Synchronization is hard. Debugging distributed training across 10,000 GPUs is a nightmare. What if you could train a frontier model on a smaller footprint? What if you could do in weeks what takes months with traditional setups? That's what Cerebras is promising. Faster iteration cycles. If you're training a model and you hit a problem on day 10, you can restart faster, try something different, and be back training by day 12. That's not a marginal advantage. In a competitive landscape where model quality is moving this fast, iteration speed is existential. And then there's energy efficiency. A wafer-scale chip burns less power than the equivalent number of separate GPUs because you're not moving data everywhere. Less heat, less power draw, lower cooling costs. When you're running billion-dollar training runs, efficiency matters. Here's the thing about a $23 billion valuation for a company with boutique customers and early product. That's not a valuation based on current revenue. That's a valuation based on belief. It's belief that the GPU-centric training paradigm is ending. It's belief that there is a post-Nvidia world and Cerebras is going to own part of it. Investors are hedging. They're not sure if Cerebras will win, but they're sure that someone will eventually move away from traditional GPU training. And if Cerebras is one of the few credible bets on that future, then $23 billion doesn't sound crazy. The narrative link is clean. If Microsoft is trying to escape Nvidia, quietly Cerebras is trying to replace Nvidia loudly. Microsoft is saying we're building our own chips in-house. Cerebras is saying we're building the future of training and everyone will buy from us. They might both be right. Probably they will be. There was a robot demo in Shanghai last month, a humanoid called Adam U Ultra. In the video, the robot walks through a room, it picks up objects, it interacts with people, and the movement doesn't look like a robot following a pre-programmed path. It looks like someone figuring things out. When you watch a Boston Dynamics robot, you see precision, incredible precision, but you see software, you see a sequence someone wrote. When you watch Adam U Ultra, you see adaptation. The robot is reacting to what's happening in real time. It's not scripted. The company that built it says it's powered by an end-to-end visual language action model, which is a fancy way of saying the robot looks at what's happening and decides what to do next, using the same kind of reasoning AI does when you ask it a question. That spooked people, not in a Terminator way, in a this is actually a different level of difficulty way. Vision Language Action Models, VLA. That's the architecture. Here's how it works. The robot has cameras. The cameras see the scene. The model looks at the image and generates an action. Grab the cup, move left, adjust grip. It's continuous stream of consciousness control, but there's something harder happening underneath. Real-time balance correction. As the robot moves, it's constantly adjusting. Its weight distribution, its center of gravity, the torque on its joints, all in real time, all while following the high-level goal the VLA model is directing. And it's learning, not in the sense of being trained on data and improving the model, in the sense of the robot making a mistake, adjusting, and the next movement accounting for what it just learned. That's learning-based motor control. It's harder than training a language model because you can't pause and restart. The robot exists in the physical world. It has to get it right the first time, most of the time. And yet, it's working. ChatGPT changed how people think about AI, but it talks. That's the constraint. It's very, very good at talking, but it doesn't do anything. Robots do. They move, they interact, they change the physical world. Language models are solved. We know how to make them bigger and better. The curve is clear. We throw more compute, more data, better architecture, and the models get smarter. Physical AI is the hard problem because the world has constraints. Gravity, friction, the fact that if you drop something, it breaks. You can't retrain a robot after every mistake. You can't restart physical training like you restart a batch. Once companies figure out how to make robots learn reliably in the real world, how to make them adapt to new tasks and new environments, that's where the economic disruption actually actually happens. Chatbots might change how you work. Robots change how everything is made, delivered, and serviced. Factories, logistics, care facilities, construction, security, defense, everything gets different. The key framing is this: ChatGPT talks, robots like Adam you act, and action is where the real economic disruption happens. Here's what's going to happen over the next 2 to 3 years. More hyperscales go custom silicon. Google pushes TPU further. Amazon builds something. Meta builds something. Apple already did. The days of everyone buying GPUs from one company are ending. Fewer general-purpose GPUs. Nvidia isn't going anywhere, but their market shifts. Instead of selling the same chip to everyone, they're selling specialized variants. High-end training chips, inference chips, robotics chips. The monopoly fragments. Robotics moves from demo to deployment, not everywhere, but warehouses, logistics, maybe some manufacturing. You'll start seeing robots actually do work that matters, not experiments, not research. Actual jobs. And we'll finally see the real cost of AI. Not the training cost, the inference cost. The cost to actually run these models in the world. Once that becomes transparent, once companies stop subsidizing AI and start charging real prices, we'll know who built something sustainable and who built hype. And if you want to stay ahead of these shifts before they become obvious, make sure to like and subscribe to Evolving AI for daily coverage of what's actually happening in AI. Thanks for watching. Catch you in the next one.